Welcome to Properties of Logarithmic Functions. Let's begin. All right, so we've got two essential questions. What are the three log properties? What does it mean when the bases of a log are equal? Remember that your summary at the end of your notes should answer your essential questions. If you want full credit for your notes so they're not late, so you don't get a late grade, then you'll write your summary and have them answer your essential questions. That's what I'm looking for this whole unit. So there are three properties we're going to work with. And the first one is the product property. Make sure you take notes very carefully so you can go back and look at these properties and memorize them. But the product property says that the log of a product is the sum of the log of its factors. So let me explain what that means. And that's if we have logs and they all have the same base, and I have m times n, then it's going to be the same as log m plus log n. Okay, so let me show you this example here. So my bases are the same, and I have log base 3, 4 plus log base 3, 7. So because we're adding them, we multiply, and we have log base 3, 4 times 7, which is log base 3, 28. Okay, so log base 328 is the same thing as log base 3, 4 plus log base 3, 7. We multiply these factors here. The second property is the quotient property. So the log of a quotient, which is this part, is the difference, so that's subtraction, of the logs of the numerator and the denominator. So if I have the same bases, log m minus log n is going to be log m divided by n, and vice versa. Log m divided by n is m minus n. So here we have the same bases. Log 20 minus log 5 would be log 20 over 5 with the same base, which is log 4. And the third property is called the power property. So the log of a power, so here's the log of a power, is the product of the log and the exponent. Okay, so we're going to multiply, that's product of the log and the exponent. So what that is I have log m to the power of p, so there's my exponent. I can move it here and it becomes p times log m, and I can go back and forth with that. So like over here I have log base 4, 6 squared. I can move this to the exponent in front of the log, and I get 2 log base 4 of 6. And it can go the other way again. So I could move this 2 back on as an exponent or back here as a multiplication to the log. It goes back and forth. That's the power property. So let's look at these three examples. Here I've got log base 392 minus log base 34. They have the same base. Since I'm subtracting, that's the quotient property. So I would end up with log base 3, 92 divided by 4, which is log base 3, 23. This next example, we're adding, so it's the sum of the factors. So that's the product property. Sorry, so this one was the quotient property. This one is the product property. So when you add, you multiply. So log base 4, 9 times 8, which is log base 4, 72. And in this last example, we're not adding or subtracting, but we do have an exponent right here, log base 8, 9 to the 7th. So I can move that exponent in front of the log, and I get 7 times the log base 8, 9. Now this next thing, it's not really a property, but we're talking about how to change the base, and we actually talked about it in the changing forms video, but I'll just show you here again. So log with a base and an argument. We can change the base to 10 by making log 10 of the argument divided by log 10 of the base. So we'll have an example here, log base 28. Remember, if we wanted to evaluate this, that was in that other video, we could just plug it just like that into the inspire. For the 84, we would need to change the base. And so we could change the base by having log base 10 of 8 over log base 10 of 2. And so in the 84, or the 83, whatever it is, you would just enter log 8 over log 2. And that's why, because you changed the base to 10. But in the inspire, again, you could just enter it in like this. But this is change of base. Changing the base to 10 is dividing the log of the argument over the log of the base. Another thing I want to talk about is when we start solving for x using logs. Just like we did the exponential equations and we solved for x, now we're going to do these logarithmic equations and solve for x. So one of the things I want you to notice is if they have the same base, then their arguments must be the same, or the arguments must be equal. So log base 3 equals log base 3, so that means x must equal 2. Right? So the same idea if we had it a little bit different, log base 3 of x plus 4, if it equals log base 3 of 5, again, I have the same base, so my arguments must be the same. So x plus 4 must equal 5, so my x must be 1. So that's this rule. If the logs have the same base, their arguments must be equal. All right, so in order to solve for x, we're going to use the 3 log properties. So that's the first thing. Make sure you use your log properties that we just talked about. And then also use the rule we saw, which was if you have the same base, the arguments are equal. So let's look at this example here. If I have log base 3 42 minus log base 3 of x equals log base 3 7. So I'm subtracting. That means I have the quotient property. So I'm going to have log base 3 of 42 divided by x. So that's what happened on this side, is I subtracted my logs. So I used the quotient property to turn it into log base 3 42 over x, and it's still equal to log base 3 of 7. Now I'm using the next rule we talked about. Same base, then the arguments are equal. They both have a base of 3, so I can say that 42 over x equals 7. And then from here I can solve for x. Multiply by x, 42 equals 7x, so x must equal 6. So that's how I solved for x with this log equation. I applied one of the log properties, and then I applied the fact that if I have the same base, my arguments are equal, and I found x. So let's try this last example together. If I have 2 log 7x equals log 7 27 plus log 7 3. So I'm going to apply one of my properties. I'm going to look on this side first. I'm adding, so I'm going to apply the product property. No, that's product. That's terrible. Okay, so I'm going to apply the product property, which would give me log base 7, 27 times 3, which is log base 7, 81. On this side, I actually have something I could do. I could apply that power property. See, there's a 2 in the front. I can move it to be the exponent on the x. So that's the power property that I'm going to use. And I move the 2 to the exponent. So I've got log base 7 x squared. Now that I have one log equals another log, and my bases are the same, that means my arguments must be the same. I'm going to move this back here. So same base, then my arguments must be equal to each other. So x squared equals 81. So if I take the square root of both sides, x has to equal 9. Please make sure that you go back through the video, and it was kind of long, and re-watch any part that you don't understand. You should have a basic understanding of these properties and the rule that if the bases are the same, your arguments are equal before you come into class. Okay, so don't copy everything down and then say I don't get it. Go back and re-watch. You make sure you understand the basic principle of this video. Okay, that's all. Bye.